This is problem number 7 from section 310. In this problem it says a dinghy is pulled toward a dock by a rope from the bow through a ring on the dock 10 feet above the bow. The rope is hauled in at a rate of 3 feet per second. Complete parts A and B. How fast is the boat approaching the dock when 26 feet of rope are out? And at what rate is the angle theta changing at this instant? First of all, I'm going to label some stuff here and say that this is my x side. I'm going to call this the hypotenuse side, so I'm just going to say h. Maybe I'll say hype. And they tell us in the problem that they want to know the 26 feet of rope, how fast is the boat approaching the dock when 26 feet of rope are out. So that means that this is 26 feet. It says that the rope is hauled in at a rate of 3 feet per second. So I'm going to say d hype over dt is equal to 3 feet per second. And it wants to know how fast is the boat approaching the dock when 26 feet of rope are out. So that means it wants to know dx over dt. What is dx over dt? It also wants to know the rate the angle is changing, so it wants to know d theta over dt. So let's start by probably figuring out what x is. We're going to have to use the Pythagorean theorem to figure that out. So let's go ahead and say that 26 squared is going to equal 10 squared plus x squared. So we go through and we subtract that. 26 squared minus 10 squared equals x squared. Do the square root on each side, so x is going to equal the square root of whatever 26 squared minus 10 squared is. So let's pull that open. (26 squared minus 10 squared is 576, and the square root of that is 24. So we've got, this is the square root of 576, and this is 24 for x. So let's go ahead and plug in 24 then. Right here. So this is 24 for x. Now we know that we want to find this dx over dt, so I think what we're going to do is we're going to use the Pythagorean theorem, and we'll say that we'll use our constant, which is 10, and we'll say 10 squared plus, we'll call this x squared, equals hypotenuse squared. And then we're going to do the derivative with respect to time. And when we do the derivative here, we end up with, well, this will be 0. This will be 2x dx over dt. And this will be 2 times hyp, hypotenuse, right? And this will be d hype over dt. Now they give us some of this information. They tell us what d hype is. They tell us it's 3 feet per second. And then they also tell us what the hypotenuse is, which is 26 feet. And they tell us what x is. Well, we found it actually just right there. This is 24 feet. So let's plug all that in. So we have 2 times 24 feet. We're looking for dx over dt is equal to 2 times, we have the hypotenuse, which is 26 feet, times d hype over dt, which is going to be 3 feet per second. When we divide that across, we get dx over dt is equal to, we're going to say 2 times 3, we're going to say, let's just do it all in the calculator at the same time. So we'll say 2 times 3 times 26, 156 feet squared per second, over 2 times 24, 48 feet. When you divide those, you end up with 48, 3.25 feet per second. So we end up with 3.25 feet per second. That is how fast the boat is moving toward the dock. Now they want us to find d theta over dt. Well, we did this in a previous problem. It's very similar. We're going to take, this is the cosine side, which is our constant. So we're actually going to use cosine of, let's go 10 over the hypotenuse. So we'll say cosine theta equals 10 over the hypotenuse. And actually we could do 10 over, or we could do x over 10. Let's do that. Let's use tangent. Tangent will be easier. We'll say tangent theta equals x over 10. This will be a lot easier. Now we take the tangent inverse of each side and we'll get theta equals tan inverse of x over 10. And then we're going to take the derivative of this with respect to time. And we get theta, tangent inverse on the inside of this derivative. I'm going to kind of write this right here. So as I do the derivative, I'll get d theta over dt equals, but I need to know what the trig inverse derivative is for tangent. So for tangent, we've got u prime over u, or 1 plus u squared. So this is tan inverse. So this is the derivative of tan inverse. So we're going to just say d over dx of tan inverse of u is equal to u prime over 1 plus u squared. So we're going to use this right here, and we're going to say that, okay, u prime. Well, u is obviously x over 10, so u prime is going to be 1/10 dx over dt over 1 plus x over 10 squared. And now we're going to plug all this in. So we're going to say 1 over 10 times, we know that 3.25 feet per second is our dx over dt value. We need to plug in x. Well, we know x in this specific situation is 24, so we're going to say 1 plus 24 over 10 squared. And now we just have to go through this multiplication. So we'll do the top one first. So 3.25 times 0.1 is 0.325 feet per second. Divided by, on the bottom we've got 24 squared divided by 100 plus 1. So we got 6.7 6 on the bottom. And this should actually be feet squared, because that's a feet right there. So now when we divide this, and this is actually, yes. So yeah, we're in the right situation. So when we divide this, we take the 0.325 divided by 6.76, and we end up with, and this angle is changing. It's getting, like, as the boat gets here, this is changing negatively. It's getting smaller, so this will be negative. We're going to call this 0.048 degrees per second. Now they might have you write these in fraction form. If they do ask you to write these in fraction form, you can use your calculator to convert that. You should end up with maybe like -5/104.